Hello and welcome back to Data Analysis and Visualization. I'm Jivita Christie, and in this video, we are going to talk about how you can add context to your data visualization and how you can select a correct data graphic type for your purpose of data visualization. So let's begin. First, you need to know when exactly you should add context to your data visualization. Adding context helps people understand the value and relative significance of the information your data visualization conveys. And adding context to calculating exacting data visualization styles helps to create a sense of relative perspective. So if you want to create this type of a sense of a relative perspective, then you would add context to your designs, to your visualizations. In pure data art, you should omit context because with data art, you're only trying to make a single point and don't want to add information that would distract from that point. So adding context would basically mean, adding some extra details or data about where exactly you are getting that representation of the graph from. But this should not be something that you do for any kind of graph. It depends on what visualization you're doing for what purpose. If it is data art, like if you want an emotional response from your viewers, from your audience, then you should not add context because context would only get them confused, and those are the parts of the graph that they may not want to look at, and you're just adding more information that confuses them. So you would want to omit context if you are working with data art. But if you're working with a simple data visualization, which is very sophisticated and then at the same time it is also traditional, then you might want to add context because then your audience would be the type of audience that would want to see the context. Now, how you can use data to create context. In data showcasing, you should include relevant contextual data for the key metrics shown in your data visualization. And data showcasing, once again, which I told you about in before a couple of videos, that is, it's the type of data visualization that is used when your audience is very analytical minded. So you're working with data analysts, engineers, scientists. These are all analytical people. So if you would want to show something to them, if you wanted to create a data visualization for them, then you would be using data showcasing. And in that case, you should add context. And an example of this would be a situation where you're creating a data visualization that describes conversion rates for e-commerce sales. The key metric would be represented by the percentage of users that convert to customers by making a purchase. So when they make a purchase, they can in the previous couple of videos where I was talking about how to increase sales in e-commerce using data visualization, there we saw the whole funnel of how customer acquisition and retention works. So one of the layers was, converting a customer into some purchaser, right? In retaining a customer, it's not just about customer acquisition, but also, enabling them to make a purchase from your e-commerce site. So in this case, you would have to have a key metric that would describe this percentage of users that are converting to being customers by making some purchase. So it's not just about, getting customers to click on your website, but also to get them to buy something. So how many of these people who actually visited your site also bought something? This percentage would be a great way to show context in your data visualization. Contextual data that's relevant to this metric could include shopping cart abandonment rates. This is another very good contextual data. Shopping cart abandonment rate is something that, people are adding, say, 10 things to their shopping cart, but then they just leave your application and they don't make a purchase. That would be shopping cart abandonment rate. So what is wrong with it? Is it that the total amount, maybe there are so many taxes, or maybe the shipping charge is so much that after adding all these things, their total bill is so high that they really don't want to buy anything? Second is average number of sessions a user has before making a purchase. So for how long is the user using your website or application before making a purchase? Is he like opening it for 10 days in a row and then deciding whether or not to make a purchase? That would be another contextual data that you could add to your visualization. Then average number of pages visited before making a purchase. This is another good information. Or what pages are visited before a customer decides to convert. So what kinds of pages or products did the customer view before deciding that he or she wanted to buy that? And this sort of contextual information will help viewers understand the why and how behind sales conversions. Adding contextual data tends to decentralize the focus of a data visualization. So add this data only in visualizations that are intended for an analytical audience. So only if you're doing data showcasing, you should add contextual information. Those are the ones in a better position to assimilate the extra information and use it to draw their own conclusions. With other types of audiences, context will only be a distraction. So if you're trying to show this type of data in storytelling, imagine showing this type of data, how many people abandoned the cart and how many pages the person visited. All this data is pretty distracting if you're trying to work with audience that's not analytical minded. And only an analytical audience would appreciate the presence of such contextual data. So you should only add it if you're making a data visualization for people who are analytical minded. Now, how to create context with annotations. Sometimes you can more appropriately create context by including annotations that provide a header and small description of the context of the data. This method of creating context is most appropriate for data storytelling or data showcasing. Good annotation is helpful to both analytical and non-analytical audiences alike. So not just showing some percentage, but maybe putting some heading, like writing something in your data visualization, maybe a sentence or a few words that could help the audience to understand your visualization better. That's called annotation, and you could add context to your data visualization by using such annotations. And this would work for both storytelling, data storytelling, as well as data showcasing. You should, of course, omit that if you are actually producing data art. So if for artistic visualizations, we do not add context at all. Now, how you can use graphic elements to create context. Another awesome way to create context is a data visualization to include graphical elements that convey the relative significance of your data. Such graphical elements could be moving average trend lines, single value alerts, target trend lines, or predictive benchmarks. So a lot of times you might have seen graphics, where there is a line, but that's like, moving. So you're adding some animation, some motion to your graphics, and that could help with, adding context to your data. Now, how exactly you can do that? You can see it right here in this graphic. You can see how exactly using graphics we have added some context, and you will see that this particular graphic that you see here is related to occupations of US labor force, and it is from 1850 to 2000. And you can see how the graph itself shows something. As you can see, there's depression. So whenever that is the case, then we are also showing it in the graph itself. So when you look at it, you can understand how it is working. So you can see that, and how females are shown with a pink area and males are in the military are shown with a blue area. So it's a very good example of how graphics can be used to add context to your data visualization. This is another good example of for the same. And you can see here as well that there are graphics. There's a use of graphics. There's this line, yellow colored line that you see, which shows you 50,000 how sales are working. So this is about sales. And you can see that yellow line that's right there that adds meaning to your data. Now, the next thing is choosing the most appropriate data graphic type. So you know now whether or not to add context to your data visualization, and how to add context. Now we are going to see what could be the most appropriate data graphic type for your kind of visualization. Now your choice in data graphic type can make or break a data visualization, because you probably need to represent many different facets of your data. You can mix and match among the different graphical classes and types, because there are so many types of graphics and options available for you to choose from. That's why you might get confused and probably choose something that is not appropriate. Even among the same class, certain graphic types perform better than others. Therefore, create test representations to see which graphic type conveys the clearest and most obvious message. So you don't just want to choose one, you want to choose many and try them all out, and then find out which one of those is working the best for the type of visualization that you want to perform. Pick the graphic type that most dramatically displays the data trends you're seeking to reveal. You can display the same data trend in many ways, but some methods deliver a visual message more effectively than others. So you need to pick the one that's right for your kind of visualization. The point is to deliver a clear, comprehensive visual message to your audience so that people can use the visualization to help them make sense of the data presented. Among the most useful types of data graphics are standard chart graphics, comparative graphics, statistical plots, topology structures, and spatial plots and maps. So we are going to see some of those here in this video. So we are going to see first the standard chart graphics. Okay, so these are the ones that are standard basic graphics that are used. And when making data visualizations for an audience of non-analytical people, you need to stick to these standard graphs. The reason for this is the more foreign and complex your graphics are, the harder it is for your non-analytical people to understand them. And not all standard charts are boring. You actually have quite a variety to choose from, as the following list, which I'm going to show you now, makes clear. So if you're dealing with non-analytical audience, then you should use standard chart graphics, which are not very fancy, because if you start using things like chloropleths, then it might happen that your audiences do not understand how that graphic works. But if you use a simple pie chart, everybody understands a pie chart, and that's why it's the most appropriate, even though it's the simplest one. So the first type is area charts. Area charts are a fun yet simple way to visually compare and contrast attribute values. You can use them to effectively tell your visual story when data storytelling and data showcasing. So for both the purposes, storytelling as well as showcasing, you can use area charts, and they are very good for comparing and contrasting attribute values. And I'll show you one here. So this is an example of an area chart. So you can see there are different areas shown with different colors, and those colors make it easier for you to understand how this chart is working. If you'd like to take a closer look, I'd encourage you to pause the video here and maybe zoom in and take a better look at this area chart. The next we have are bar charts. Bar charts are a very simple way to visually compare and contrast values of parameters in the same category. And they are also best for data storytelling as well as showcasing. Here is a bar chart. This is what it looks like. You can see there's x-axis and y-axis. All the parameters are mentioned on x-axis. And you can compare all the parameters with each other by seeing these bars that are created. Next, we have line charts. Line charts most commonly show changes in time series data, but they can also plot relationships between 2 or even 3 parameters. And line charts are so versatile that you can use them in all data visualization design types. So they are versatile, can be used anywhere, and mostly they are used in plotting time series data. If you don't know what a time series is, you can watch the video on time series that I have created. You'll find it in the description box. So you can, using line charts, you can plot relationships between 2 or 3 parameters, and they are versatile, can be used in almost all kinds of visualizations. Here is an example of a line chart. You can see how it is created, and this is about total land area in Northeast states, and these are all the states and their land areas, and we are showing it through a line chart. The next is pie chart, which is a very simple and humble type of representation that practically everybody knows how to make and how to interpret. Pie chart graphics are among the most commonly used. They provide a simple way to compare values of parameters in the same category. Their simplicity, however, can be a double-edged sword. Deeply analytical people tend to scoff at them precisely because they seem so simple. So you may want to consider omitting them from data showcasing visualizations. So often pie charts, because they are so simple and humble, you don't really want to use them if you are showing a visualization for a deeply or highly analytical audience. Then you might want to use something more sophisticated. But if it's an audience where people are not really worried about how good it looks, but they really want to just see the data and understand it without going much into analysis, then you would use a pie chart. And I don't need to show you this, but I'll just go ahead and give you an example. This is a pie chart, and it's very simple to understand. You just have to look at all the colors mentioned here, and you'll know which part is showing what. And comparison is very simple. You just know that anything that covers larger area is more compared to anything that covers lesser area. So you can once again pause and take a look at it. And I'm going to end this video here, and in the next video, we'll see some more types of graphics that you can choose from. So I'll see you in the next video, and thank you for watching.